Hello community, I am Aayush Kumar and today my presentation is about basics of networking and understanding net networks. So we will see that how the simple things in network are going on and how our rigs are connected, how liquid galaxy is connected, and some basic things of and basic terminologies of networking. So let's begin. So, so basics of computer networking. So there must be a question that what is this networking, computer networking? So it is just a practice of connecting computers and other devices together to share some kind of information and resources. So it basically enables communication between devices over a network. So like we have our Liquid Galaxy rig. So we are connecting multiple uh, windows or multiple displays, and we are just synchronizing them. Uh, it is a example of networking. So So what is the importance of networking? So what are the main functions of networking? Why we are using the networking? So the first thing is that we are sharing some kind of resources. Like the resources may be the printers, files, and internet connection. Like in our Liquid Galaxy, we have three displays which are sharing one Google Map, and it is synchronizing and showing them one Google Map or just one map, and these are synchronizing or all the three using the networking. Second is communication, so like emails, instant messaging, and video conferencing. These are also done by networking. We all know. So like our main host was communicating by the other two or other displays by the networking. So they are communicating, sending the different messages, different KMLs on the other displays. Third is data exchange. So it is important for some crucial business operations, cloud computing, and data storage solutions. There we are exchanging some kind of data, like on the drive we are uploading the data, and on the YouTube we are seeing the videos. So this is kind of network. Now, what are the key components and what are the key devices that are used in networking? So we will see them one by one. So first thing that in a networking is the IP address. So what basically is an IP address? It is like a unique identification that each device in a network it is giving. So specifying its host network and location for the data transmission. So each IP address identifies the device's host network and its location on the network. So like when one device sends data to another, the data includes a header and that includes the IP address of both the sending and receiving devices. So here is a header which includes both the addresses of the sending device and the receiving device. We can see the two components here in the image of the IP address. So first one is the network identity, which identifies the network, and second is the host identification, which identifies the computer. Next thing is node. So node is basically it is a network connection point that receives, send, create, or store data. It is essentially it can be any network device, like it can be a computer, printer, modem, bridges, or switches that can recognize, process, and transmit data to another network node. So each node here requires some form of identification. So we have seen that IP address. This is the uh, identification for each node. So IP address or maybe the MAC address to receive access to the network. Moving to the next one. The next one is routers. So routers is like a physical or virtual device that send packets, data packets between the networks. So routers analyze the data within packets to determine the best transmission path. So it finds the best path which can be used to transfer the data, and then it uses some sophisticated routing algorithms to forward data packets until they reach their destination node. So like in the image, you can see there is a router between the two networks. This is our LAN, a local area network, maybe, and this is another network, another local area network, and this router is just finding the path and then sharing the data packets among these two networks. Next thing is switches. You can see these switches. So switch is a device that connects network devices and manages node-to-node communication. So it makes sure that data packets reach their intended destination. Unlike routers, so uh, which send information between networks, switches send information between nodes within a network. So in the image, we can see there are two. We can see that this is the one network here and another network is here. This router is sending the information between these two networks. But what the switch is doing here, it is basically sending this information between these nodes. This PC1 is a node and this PC2 is a node. So this switch is sending the data to its destination. Uh, like if we want to send the data on PC1, then this switch will do this thing. Uh, Moving to the next one. So next one is port. So port indicates a specific connection between network devices with each port identified by the network. What like if an IP address is analogous to hotel address. So this is an example. If we take that IP address is a hotel address, then ports are the streets or the room numbers. So computer use these port numbers to determine which application or which service or which process should receive which message. Like we have to give a service to a particular room number in a hotel. So that room number is recognized by a port. So like here, there are two devices which have this client IP address, but they are recognized in this network. The destination is recognized by this port number. There may be the same IP address, but different ports. Next thing is gateways. So gateways are the hardware devices that facilitate communication between two different networks. So like routers, firewalls, and other gateway devices use rate converters, protocols, translators, and other technologies to make inter-network communication possible within otherwise compatible devices. So it is just communicating between these two networks. So it is communicating between this network two. Here there may be a router from this network two, and there is a router here from network one. Mm. Then these are the some basic components and the devices. Now we will see that what are the network architectures. So how the things or devices are like basically arranged in a network. It is a architecture, network architecture. It may be of two types, like peer-to-peer architecture, which is also P2P architecture, and client server architecture. So P2P or peer-to-peer architectures, it doesn't require a central server for the coordination. Like here, we can see that there is no central server. So instead, each computer on the network acts as a both client. What is a client? A computer that needs to access a service, and it also acts as a server also. So server is a computer that provides services to the client. So here each computer is itself a client and a server also. But on the other hand, if you see the client server architecture, there is a central server here. So a central server, there may be a group of servers that manages the resources and delivers services to client devices on the network. So these are clients, and this server it will give the services resources to the clients. The client in this architecture doesn't share their resources and only interact through the server. So this computer will not directly interact with this computer. It will firstly communicate to this server, and then this server will communicate to this client. So these are two types of network architecture. Uh, so the next thing is network communication protocol. Now, to communicate or to transfer the data, there are some set of rules that every node on the network must follow in order to share and receive the data. So there are two types of this communication protocol mainly. Like many modern networks run on TCP or IP models, which include four network layers. So you can see the TCP IP, here are four network layers: application layer, transport layer, network access layer. But there is an OSI model. We will talk about these both in the next slide. It has seven layers uh, with a specific role, making it easier for engineers to understand how networks work. So let one by one just talk about them. So first is the TCP IP. Basically, this stands for Transmission Control Protocol or Internet Protocol. So it has basically four layers. First one is network access layer. So this network access layer, it handles physical data transmission using Ethernet or protocols like ARP for communication within the same network. So it is communicating within the same network using the Ethernet. Second is internet layer. So it manages logical addressing, routing, and packet forwarding using IP and ICMP. These are some protocols. Transport layer, then third is transport layer, which ensures reliable or fast data transfer between devices. Uh, with TCP provides error checking, and with UDP, it supports the real-time applications. Fourth one is application layer. So application layer, it directly interacts within applications using protocols like HTTP, FTP, DNS, and SMTP for network services. So you have seen in the apps while building the app that HTTP networking is used to fetch some data from internet using the APIs. So this model, TCP/IP model, so it ensures the efficient and structured communication over networks. Now the second one is open system interconnection model. So it has the seven layers. Let's talk about these seven layers one by one. So here the first one is same the application layer, which creates the data to be sent just like in the TCP/IP. That is directly sharing the data between the applications. You are fetching the data using some HTTP, FTP, SMTP. Second one is the presentation layer. It is where the data gets encrypted and decrypted to send up to the application or down to the session layer. So presentation layer, it is like the data is transferring in some binary representation, like so the data will be encrypted and decrypted at this layer. Third one is session layer. It has a connection that manages the session happening between the applications. So it starts the session that let's say start a session and one network is communicating with the another network. Fourth one is transport layer. So transport layer, it basically determines the route, that which route we have to select for uh, transporting the data from one uh, one point to another in a network, one node to another in a network. So it is basically just a route that the packet will take to reach its destination. Fifth one is network layer. So network layer, it provides the packet with its address and routing instruction to be sent to the data link layer. So network layer, we give it a address and instruction that where you have to go. Sixth one is data link layer. So it establishes the point-to-point connection with the destination to be sent. So data link, when the data is reached to data link layer, then it directly connects to the destination. Then the last one is physical layer, which sends the data in the required format. Now, so we will see a basic example that how does a computer networking works. So let's see an example of you are sending an SMS or email to someone. Then you are just composing the email and then just press the send button. So what happens that SMTP, So, and POP3, these are the transmission protocols which send the email using the Wi-Fi or using the network, internet connectivity. Then this email will be broken into small packets. So there's a large chunk of data, then it will be broken down into the small chunks of data. And these packets are compressed and routed to the recipient. Then after that, the data format and protocols are adjusted. So data format, it will be converted into some like 0, 1 representation, binary representation, and then the protocols adjust the data, encrypt that data, decrypt the data. Then this data will be transferred to the recipient's network, which receives the data, recipient's network, and then recipient network gets that email. So this is a simple example how this computer's networking is working. Uh, so this is the some basic things about the networking, basic terminologies, and just a basic function. So you have now a basic idea how the networking is happening. Now just see how and what is the NAT we are using in our virtual box, and we are using it to connecting our 3 displays or 5 displays in our little galaxy. So let's understand what is network address translation or NAT. So now in the network, we are giving it a IPv4 address, but IPv4 addresses are limited. We can't give every device in the network IPv4 address. So this NAT or network address translation, it is a solution. So NAT allows machines from within a network to communicate with another network as they are leaving the network with the same IP. So what it do, like you can see in the example image, here are 3 PCs which are connected together using a server. Uh, these three have a like IP address. You can see it has a 192.168.0.2. It has zero point 0.3, it has zero point 0.4. But what NAT does that it will give them a single address here. So like 192.168.0.1. And this IP address is used to communicate to the external or the wide area network here, or connecting to the internet. So this is the basic illustration of NAT, what it does. So what are the benefits of NAT? Why we are using the NAT? First thing is private IP address. You can see that there are 3 IP address, and then just this router, it transform them to just one address, and then it will give another public address which the internet can see. So internet will assume that this IP address is used to connect all these three. Internet can't see uh, this IP address like 174.122.1.14. It will see this IP address, public IP address here, not this private IP address. So it allows you to rescue the private IP address. So thus it provides you the good security also. It has a good security feature. It enhances the security of private network by separating the internal network from the external network. So we are separating the private IP address and public IP address. So how we are separating the internal network and external network. Third one is conserve the IP address space. So we can connect to a large number of hosts using a small IP address to the global internet. Like we can connect up to 50 machines in a single IP address. Then how this net is working. So now just see this image. I try to explain from this. So we have a network in which these two machines are connecting to each other. So it has an IP address 192.168.0.3 and it has a point 2. So like assume that it is sending some data. So this is the sender address, IP address, and it is the sender port. You can see that their port is also different. You can see it is 3000 here, it is 9000 here. And its destination is the internet server, HTTP server. So this one is the IP address, and we know that it is has the port of 80. So now this will convert it into a private to public address. So this address will be shown to uh, the public or internet. So now this router will change the sender address to 200.1.1.1, and just it will use the port to differentiate between these two machines. You can see that here the sender IP address is same here and also the same here, 200.1.1.1, but the sender port is different. So we are using only one IP address for both these devices to connect to the main internet, external network. So that is how it is working. Now it will creates or generates a NAT table. So for the wide area network IP this and port this, the router have to connect to this machine, 192.168.0.3. So this is the mapping table that the NAT uses to connect in a network. So I hope this is clear to you. So there is a one more important component in the NAT network. There's a DHCP server. What is DHCP? So it is Dynamic Host Configuration Protocol. So it automatically provides and assign IP addresses, default gateways, and other networking parameter to the client devices. So like these are the two client devices. So this DCHP server will automatically assign them a IP address. So DHCP server automatically sends the required network parameter for clients to properly communicate to the network. Now the router will it will also give them a host name or port number. Then the router will use that or port number to distinguish between these clients. So that is how the network or NAT is functioning. So thank you. Here my presentation is over. I am Aayush Kumar. Thank you.